Hi everyone, welcome to myself, Katrina and James's presentation of reproducibility in biomedical science. If you haven't already, could you please answer question 1 on the survey for us, please? Okay, so the reproducibility crisis. Over the last 20 years or so, the evidence has been mounting that much of the literature published in journals cannot be replicated. In 2005, John Ioannidis estimated that half of all research findings were false, although some estimates place this higher. More recent work cites a continuation of this theme and of the contributory problems. In 2015, Friedman et al. Used this 2005 estimate of 50% to calculate the economic cost of irreproducibility in US preclinical research, with this coming to a staggering $28.8 billion that was potentially wasted. Later, in 2016, a survey published in Nature found that of 1,576 researchers, 52% believed there was a significant crisis, and 38% believed there was a slight crisis. This, of course, making up 90% of the total researcher population they surveyed believing there was some form of crisis. Among this group, they self-identified that a better understanding of statistics was the #1 factor that could boost reproducibility. So today, we want to discuss with you and gather some of your opinions on some statistical aspects that may contribute to the crisis. If you could now all answer question 2, please. One of the primary factors we obtain with statistics in biomedical is, of course, the p-value. And at the current moment in time, in the literature, the p-value is dichotomized, and this is often around the 0.05 threshold. A treatment of the p-value in this way is worthy of consideration, because right from undergrad, we effectively begin to dichotomize the p-value and use it as a binary yes-no answer to the question of a piece of data's significance, and therefore often its value to us. But the real difference between a p of, say, 0.04 and of 0.06 is actually quite small. If we strip back what the p-value actually tells us and represents, in this case I'm presenting a normal distributions from a common t-test, what we see stripped back is the p-value is not a categoric variable as we seem to treat it, but rather more of a continuous variable of likelihood. A small p-value is produced when the means are further apart and there is less overlap between the distributions, and in this case the standard deviation, between two populations, so they're effectively more distinct. If I could ask you all now to answer questions 3 to 7 on the survey,